Hello everyone, welcome to Vamani Farm Lectures, where pharmacy is made simple. My name is Vamani Gerard and I am a tutor. In today's lecture, I am going to take you through Pharmaceutics 4, particularly done by pharmacy students. These are normally called palatal preparations, to be specific injections. So we shall look at our first scenario where we are provided with the formula below, and they are asking us to provide a working formula for preparing 6 bottles of an infusion, each containing 250 ml. And the molecular weight of sodium chloride is provided as 58.5. Potassium chloride is provided as 74.5. And dextrose 180. So how do we handle such a question? First of all, we look at the ingredients of the formula provided, where we have sodium chloride 154 millimole, potassium chloride 40 millimoles, dextrose 278 millimoles. Then all these are contained in 1000 ml of that solution. So the first thing to do, if we have to provide a working formula for preparing a preparation of this kind, one, we need first of all to find the final volume of the preparation. Because in our question, we have been told to prepare 6 bottles, but each bottle of the infusion contains 250 ml of that solution. So we shall begin by calculating the total volume of the preparation required. So from first principle, we shall say that 1 bottle of an infusion contains 250 ml of solution. How about the required 6 bottles of an infusion? They will contain 250 divided by 1 times 6, and this will be still in mils. And finally, we shall have 1500 ml. So, the volume required to prepare this injection or this preparation is 1500 ml. So now, after knowing that this is our final volume of the preparation, we are now going to obtain the quantities of each of these ingredients required in the required volume of 1500. Let us see. But remember, when preparing such an injection, one, you look at the units of the ingredients provided. The units given here are in millimoles. And there is no way we can weigh them on our usual weighing balance. So we shall have to convert these units into weighable quantities of mass. So let us obtain quantities of each ingredient in 1500 mils. And we shall begin with sodium chloride. So here, they have told us that 154 moles are in, 154 millimoles are in 1,000 mils of the preparation. So we need first obtain how much millimoles are in 1,500 mils of the required. So from first principle, we shall say that 1,000 mils of the solution contains 154 millimoles. How about the 1,500 mils of an infusion? It will contain 154 divided by 1,000 being multiplied by the required volume, which is 1,500 mils. And when we compute this, we shall get 231 millimoles of sodium chloride. So now, after obtaining the 231 millimoles of sodium chloride, remember, still that is unknowable quantity or units. It is still in units that cannot be weighed, in other words. So we are going to convert those units into weighable quantities of mass. But remember, millimole is 1,000th of a mole. And therefore, that means that 1,000 millimoles are equivalent to 1 mole. But from molecular weight, we are all much aware that molecular weight of sodium chloride, for example, is 558.5 grams per mole. So that means molecular weight is the mass of a substance in 1 mole. And therefore, that gives us a relationship between the 1,000 millimoles and our mass, which is the 58.5 grams of sodium chloride. So after knowing that, therefore, we are going to say that 1,000 millimole of an infusion is contained in 1 mole. But since 1 mole, according to molecular weight, is the mass of a substance, so the 1,000 millimoles will be contained in 58.5 grams of sodium chloride. Now, how about the 231 millimoles of an infusion? It will be contained in 58.5 over 1,000 being multiplied by the 231 The millimole and the millimole will cancel, and by calculation, we shall have 13.51 grams. That's if we round off to 2 decimal places. So the mass of sodium chloride required in 1,500 mils is that of sodium chloride in 1,500 mils, which are the 6 bottles. So we want also to obtain the mass of potassium chloride. But remember, the one provided in the formula, it is in 1,000. So we shall first begin by obtaining the mass in the required volume, the millimoles in the other volume. So therefore, we shall say that 1,000 mils of an infusion contain 40 millimole of potassium chloride. How about the 1,500 mils of an infusion? It will contain 40 divided by 1,000 times 1,500. The mils and the mil will cancel, and we shall have 60 millimoles of potassium chloride in 1,500 mils. So after obtaining what is in 1,500 mils, remember our aim is to convert the millimoles into weighable quantities. Therefore, we are going to say, according to the relationship we have between millimoles and molecular weight, we shall therefore say that 1,000 millimoles of an infusion is contained in 74.5 grams of potassium chloride. How about the 60 millimoles? So the 60 millimoles of an infusion, it will contain 74.5 divided by 1,000 times the 60. The millimoles and the millimoles will cancel, and we shall remain with 4.47 grams of potassium chloride in our required volume. Let us now also look for the quantity of dextrose. We are aware that dextrose is a non-electrolyte, and therefore, according to the relationship between millimoles and moles, and also the molecular weight, we shall say that 1,000 mosmole of an infusion is contained in 180 grams of dextrose. How about the 278 mosmoles of an infusion will be contained in 180 divided by 1,000 times 278. The mosmoles and the mosmole will cancel, and we shall finally have 75.06 grams of dextrose in the required volume. To take you back a little, we want to know why are we saying 1000 moles is equivalent to, is contained in 180 grams of dextrose. Most more, just like we looked at millimoles, most more simply refers to a thousands of osmol. And therefore, 1000 mosmol is equivalent to 1 osmol. But 1 osmol is equal to or equivalent to 1 mole, of which we are all much aware that from molecular weight, the mass of a substance in 1 mole, that's why we are having a relationship of this nature. We can also obtain the quantity of dextrose from the formula, where we know that mosmol per liter is given by concentration being multiplied by number of species times 1000 divided by molecular weight of that substance. Therefore, working formula for preparing 6 bottles each containing 250 ml will be sodium chloride 13.51 grams, potassium chloride will be 4.47 grams, then dextrose will be 75.06 grams, then water for injection add to 1500 ml. That will be our final product formula for the preparation